Now let's take a step back. Okay. Again, I'll put everything in context. The first question I have here is this. What would happen? Think about this. Okay. Sorry. So the question here is this. We'll come back to some of your questions. Please post your questions in Q&A. I'll answer them in a short while. The question that I have here is this. What would happen if we don't shuffle or permute? What would happen if we don't shuffle or permute? Again, please take a couple of minutes. The time is 10:48. So till 10:51, think about it. Please type your answer in the chat window with justification. Don't just say this will happen. Please give a short justification, 3 minutes, or let's give you 4 minutes. Sorry. Let's take 4 minutes. 10:52. Again, in the shuffle, in the permute thing, right? We combine, we reshuffle or rearrange and permute. What if you don't do that? Okay, let me show you the steps in case you don't remember the steps here. Okay, these are the steps, right? First we combine, then shuffle, then split, then compute the median. What if we don't shuffle? What if we don't shuffle? What happens then? What would happen? Tell me exactly what would happen and why that would happen. Think about it. Again, understanding why each step is there is very important. Take a couple of minutes. Again, some of you are saying it will result in a biased outcome. Can you explain what you mean by biased outcome? Because bias can be different types of bias. Please elaborate. Again, I'm only talking about the shuffle or the permute or the rearrange step in the permutation resampling test, nowhere else. Only in this context I'm discussing. I see a lot of answers here. Very good. Very good participation, folks. There is a mathematical way of thinking. There is an intuitive way of thinking. Okay, very nice. Very good, very good. Just in the interest of time, this time we don't have networking, but I'll enable it later. Cool. So given that it's 10:52, a lot of you are correct. I'm very happy that you're participating actively. It's all very important whenever you're learning a technique to ask, what would happen if you remove this, right? So imagine, okay, so this is your combined stage. You're combining XC and XT. No shuffle, right? No permute or no shuffle or no rearrangement. Then what happens? This whole S1 is going to be equal to XC. This whole S1 dash is going to be equal to your XT, right? So then what happens? Let's think purely mathematically. Then we'll come to the intuition. If there is no shuffle or no permute, this is exactly going to be equal to XC, and this is going to be exactly equal to XT. Then what happens to median difference? The median difference 1 will be exactly equal to the observed difference. And even if you repeat this experiment k times, right? So even if you repeat this experiment, just a second. So, okay, even if you repeat this experiment k times, each of the times, because you're not shuffling anymore, your k observations, your m1, m2, mk, all of them will be equal to m observed, right? Then the probability that you will observe that m is greater than equal to m observed under the null hypothesis, there is no null hypothesis. The probability that this happens is equal to 100%, right? So it's completely useless. On the other hand, if you think intuitively, this is pure mathematical thinking, but if you think intuitively, what did we try to do with shuffling? Again, what do we want to compute? We want to compute, look at this, we want to compute the probability of m greater than equal to m observed under the null hypothesis. Okay, this is sometimes referred to as the null hypothesis, by the way. I just used that word here. I'll elaborate the terminology in the second part of this session, right? In second session, basically. So don't worry about the terms. Terms can be slightly confusing. The key thing here is we are not simulating that xc and xt are the same. We are not simulating it, because what are we doing here? We are by not combining them, we are not creating one large pool from which we are resampling. We are taking same xc, same xt, right? So whatever this sample S1 and S1 dash are not random samples from the universe. If, again, we wanted to compute this probability under this assumption, right? So if xc were same as xt, right, what we are computing here is completely useless from a probability standpoint, because this sample which is created is a biased sample that we got. It is not a completely random sample. If xc and xt were the same, if xc and xt were the same, and you combine all this data, if you don't reshuffle this data, if you don't completely reshuffle this data, you're generating the same sample every time. It's no more random sampling, right? Without random sampling, you can't say that you're simulating xc and xt to be the same. So you're doing what is purely non-probabilistic selection, okay, thereby creating a bias in the selection, as somebody rightly pointed out, right? So it's useless, to put it bluntly.